Hello, everyone. Thank you for joining us today at the Greater Milwaukee Safety Council virtual webinar. For those of you that this is your first time with experience with the Greater Milwaukee Safety Council, we are a group of safety professionals in the Milwaukee region that typically meets in person, but because of COVID, of course, we've had to throw an audible. But we are very excited today to have a great presentation to present for you on this rainy Friday. Elements of a respiratory protection program. We have 3 rock stars that are going to be presenting today. So I'd like to just read a couple of bios first of the presenters. We have Rebecca Seevers. Rebecca has over 30 years of blending technical and management responsibilities, leading EHS teams of companies including General Dynamics, Target Corporation, and Medical College of Wisconsin. She currently provides consulting and occupational hygiene services to companies in the pharmaceutical industry, as well as general manufacturing. She does some pro bono work and commits to donating at least 5% of all company profits to charity. Thank you, Rebecca, for being here today. Next up, we are going to have eric.pylkas. Eric has 16 years of experience in planning and performance of numerous sampling events. He is using a wide array of media and equipment to determine workplace concentrations, noise levels, emission rates, and/or indoor air quality concentrations of various chemical, biological, and physical agents of concerns. He is a certified industrial hygienist, certified safety professional, certified hazardous material manager, and the principal of Insight IH Consulting, an industrial hygiene consulting firm located in the Milwaukee region. And last but not least, we have Dr. George, I was just going to say G, but I'm going to try to pronounce it, Gruetzmacher. Dr. Gruetzmacher has been assisting Wisconsin small businesses for over 30 years with OSHA on-site consultation programs. You may know him through his work with Wisconsin. In that capacity, he's collected hundreds of visits performing industrial hygiene exposures assessments and on-site evaluations, providing abatement and control assistance, and delivering client and outreach training. He also has been a part of faculty teaching workplace health and safety courses at UW-Whitewater. George is also a fellow of the American Industrial Hygiene Association, a former board member of the ACGIH, an active member of ASP, and a long contributor to the Wisconsin Safety Council. So we thank you, all 3 of you, for joining us. We thank everyone on the webinar today for coming out as well. Without further, I'll make a couple of housekeeping notes first. There is a chat feature. So on the right side, if you do have any questions, please feel free to reach out to the presenters via that chat. We will wait till the end of the presentation to answer any questions that may come up. If you are having any audio or video issues, please log off and log back in. Usually that does fix it. If there's a room issue, I will be monitoring that as well. So without further ado, I would like to introduce our first speaker, Ms. Rebecca Seevers. Go ahead, Rebecca.
Hi, thank you for joining us. The idea for putting this together was really born of getting requests to do fit testing, and I said I would be happy to do fit testing. Send me your approved medical, and they're like, what? So there's a lot of people out there that work, some in healthcare, but other institutions as well, that don't know when they need what. And so I thought it'd be good to get something out by this means, in just to talk about what's needed when you ask someone to wear a respirator or someone volunteers to wear a respirator. So that's the things we're going to talk about today. The agenda, we're going to talk about what those written program elements are, what OSHA requires in the written program. Talk about procedures for how respirators are selected, the protection factors of various respirators, medical evaluations, how often they have to be done. Do they have to be done at a certain frequency? Talk about respirator cartridges, if that's the kind of respirator you're using, and how to determine how long those cartridges are good for. We'll spend some time on fit testing, respirator maintenance, and then we'll go into training requirements and program evaluations, and we'll finish up with some common mistakes, just a few pictures we see of things that typically that go wrong or can go wrong. So the actual written respiratory protection program for your company is needed whenever you are requiring respirators, whenever you as the employer are requiring respirators, or if it's necessary to protect the health of the employee. And what that's alluding to is really the voluntary program in some instances, and we'll go into that. So that written program covers work site specific procedures. This is the how, what, when of a respiratory protection program. It defines who the program administrator is, and this person oversees the program and evaluates the effectiveness of that program. So it's whoever is assigned to be that program administrator has to have appropriate training or experience commensurate with the program. So if your program is only involves N95 respirators, for example, and it's a fairly simple program, the level of training for that program, the person who is overseeing the program doesn't have to be quite as much as if, for instance, you did you had people wearing SCBAs for rescue or for spill response, or you had supplied air respirators, so things like that. So there are different levels of complexity of programs. You can look online and you can find respiratory protection programs to download and use, but they really need to be customized. It's not a one size fits all. And I've seen it where people have downloaded a program and called it good, and it's nowhere close. So as I said, you have to define the program administrator. And this is the person who typically would write the program, oversees the program in general, checks to see how effective it is. And we'll talk about this. I'll come back toward the end of the presentation and talk a little bit more about how to evaluate the program. And like I said, it's qualified to do this by experience or by training. Voluntary use. So what happens if a worker decides they want to voluntarily wear a respirator? And there are employer obligations if somebody wants to bring a respirator from home, or if the employee provides their own respirator from home, or if the employer provides it for the employee. So we're going to talk a little bit about that. What kind of respirator is it? So if it's a filtering face piece, and OSHA defines that as it has a fabric filter, but it is considered a tight-fitting respirator, and it is a respirator. I've got a picture of a couple of N95s here. What are your obligations? So you have to ensure that no hazards created by the respirator itself. You have to provide Appendix D. You do not have to have a written respiratory protection program in this case. And the assumption is that there is no hazard, there is no exposure above a regulatory limit or a occupational exposure limit, so that if they didn't wear the respirator or they weren't wearing it correctly, there wouldn't be a health issue. So an example might be, let's say a worker decides they want to wear a mask when they're sweeping the floor, and there's no way, there's good evidence to show that they're not kicking up enough dust, but they just don't want to breathe anything. So they want to wear an N95. That's considered voluntary use. So if that same let's take that same person again, and they're sweeping the floor, and the supervisor says, "Hey, I want you to wear an N95 when you do this task." You have just gone from voluntary use to mandatory use because someone, in this case the supervisor, has made a determination that there's a health issue there and that this person should wear an N95 when they're sweeping the floor. So that's how something that's voluntary could become something that's mandatory. And in that case, the whole respiratory program comes into play, where you have to do fit testings, you have to do a medical, you have to do the training. So that brings in the whole program. Or, so the one option is an N95 or a filtering face piece, or if it's an elastomeric respirator or a PAPR. I've had people bring a PAPR into work to wear when they didn't necessarily need one. So in this case, if it's an elastomeric respirator, you have to ensure that no hazards created by the respirator itself. You have to, again, provide Appendix D, but you also have to implement a respiratory protection program, even if it's voluntary. And this is if you give them a respirator or they bring their own in from home. And the parts of the respiratory protection program that come into effect is you have to do a medical evaluation. And you have to train them to make sure they know how to clean, to store, and maintain that respirator properly so that the respirator itself doesn't become a health hazard. You know, that they don't leave it on the shop floor collecting contaminants or lead dust or whatever it is that they're exposed to in the workplace. So if the same worker we talked about earlier that is sweeping the floor decides he wants to bring in an elastomeric respirator like the one pictured on the top, that brings the respiratory protection program now into being. So now you have to provide a written respiratory protection program. You notice I didn't talk about fit testing. No fit testing is required. Why? Because there is no hazard if they did not wear it. So that's the element there. Why no fit testing is required. If it doesn't fit quite right, if they're not doing things quite right, it doesn't necessarily create a health hazard for them. OSHA does encourage people not to wear beards or facial hair, but they can't enforce that on the voluntary program. I'm going to hand it off to Eric to do the next section here.
Hello. Thank you, Rebecca. I'm going to talk a little bit about the procedures for selecting respirators. OSHA has a full respiratory protection standard, 1910-134, that states employers shall select and provide appropriate respirator based on the respiratory hazard to which the worker is exposed and workplace and user factors that affect respiratory performance and reliability. It's a pretty long standard. There's a couple things I'm going to highlight out of it that are of particular interest, what I'm talking about here. One of them is, it does state that you should select a NIOSH certified respirator. I'm going to talk a little bit later on the next slide about some concerns regarding with NIOSH approvals. You want to identify the respiratory hazard in the workplace. You can accomplish that multiple ways. The air sampling, personal breathing zone sampling for employees is the most common means of doing this. It gives you really good data. It gives you exposure data off that person. That's the most common route of doing it. You can also do theoretical calculations, basically assuming a certain evaporative rate for a certain amount of chemical. That's certainly a doable thing. The problem with it, a lot of times you have to make assumptions that are pretty protective and conservative. You have to make assumptions that are typically going to put you in a higher form of respiratory protection in a lot of ways. But it is an option, and there are examples where those are certainly a reasonable thing to do, depending on what the process is that you're selecting a respirator for. You can also use other objective data. SDSs often have respiratory protection listed on them. Often you want to be careful with that kind of stuff. A lot of times I'll see a lot of times people will look at the SDS, and if it states as a form of respiratory protection, they just use that form of respiratory protection. A lot of times there's not necessarily good data that backs up those statements on SDSs. So you definitely want to have some confidence that what you're using is going to be protective for the employees. Industry-wide exposure studies, manufacturer data, there's other things that are available too. As with everything that you're using with this, you want to make sure that it's accurate data. You don't want to be challenged on it down the line and basically say, well, that's what it said in the SDS, so that's what we're doing. You kind of want to have some knowledge and understanding of what your exposures are. That's why I always refer to personal breathing zone sampling as a way to verify that. I think that's the easiest way to do it, and it gives you the really good data for determining exposures. If you can't estimate the employee exposure, the standard says that you need to consider it to be an IDLH. And IDLH are immediately dangerous to life and health, and they're going to be very high limits. Typically, if you're going to use that for the initial respiratory protection, you're going to have them in very significant forms of respiratory protection due to the concentration that is there. Usually that would be something that maybe you would defer to on brand new processes where you don't have a means of assessing it until you get it in there, and then you're going to go ahead and collect the baseline sampling data and get them out of it. That's often a way that people will approach that. You also want to select respirators from a sufficient number of models and sizes. Everybody's faces are different. Some people will have very good fit with a certain type of respirator and can't get any kind of fit with the other. That's going to bear itself out in fit testing if it's required. That's going to be something that you definitely want to consider when it comes to what you're offering your employees. The one thing I wanted to talk about was counterfeit NIOSH respirators. This wasn't really a thing that was a big concern with the NIOSH approvals until the pandemic came along. Then N95s became very scarce and very expensive. And because of that, there's been a big rush of different suppliers that have filled that void. And a lot of them have not gone through the necessary channels to get NIOSH approvals. And it hasn't stopped a lot of them from still placing NIOSH phrasing or NIOSH wording on the respirator. You can see that a lot of them on the, like the two examples on the right, if you look at that YARC one on the lower one, that actually is mimicking 3M's packaging. I would anticipate that them putting NIOSH N95 on their respirators because that's what 3M puts on theirs. It's just basically a replica of what a 3M respirator is. You can't use those kind of respirators because they haven't been approved by NIOSH. You can look at the respirators if you're getting them from, the problem that you have with these is the supply chains that these things come into the country. Amazon's become such a huge player. It's easy to get things straight from China or other countries that haven't gone through the necessary, proof and approvals from NIOSH before it's being put on the market. There's a number of things you can look at. There's markings on the filtering face piece respirators that are required by NIOSH. If there's no markings on the respirator, it's not going to be an approved one. There's an approval number on the respirator or headband. Oftentimes they'll spell NIOSH incorrectly. Any kind of decoratives on the face piece is definitely going to suggest it's not NIOSH approved because typically they don't approve those kind of things. Anything that says that it's approved for children, NIOSH doesn't do any approvals for children. So you wouldn't really be using that in an industrial facility. But if you saw a style of respirator that said it's suitable for children as well, then it's probably not NIOSH approved. Anything that uses ear loops instead of headbands is also not going to be NIOSH approved. There's ways that you can check your respirators. They have a NIOSH certified equipment list and a NIOSH trusted source page to determine, if your respirators that you're using that you found that employees like and you have a decent means of obtaining them for when they're required. You can check them through that to make sure that they're appropriate respirators and they're actually protecting employees. And it's not just something that's a cheap knockoff of something that's actually protective. I'm going to talk a little bit about the collecting of the air samples. I'm an industrial hygienist by trade, so this is the thing I'm most interested in. Collecting the air samples, like I said before, this is the most common means of determining the worker's exposure when you're trying to get respirators in place and select proper respirators for the task at hand. Personal breathing zone samples are going to be the preferred way of doing it. The other way people will often collect samples is through fixed area samples. Those are dicey to use as proof for anything because they tend to miss a lot of the exposures. If you had a person that was doing a sanding operation and you put a background monitor as a fixed area monitor, it's going to measure some of the dust that's generated, but it's not going to measure everything that's in that breathing zone that the employee is exposed to. There are cases that you might be able to use an area sample. If somebody was in a control room and just sat on a chair looking at a computer for the whole shift, maybe a fixed area sample would be more accurate and something that you could potentially use. I just prefer to use breathing zone samples. It takes all the guesswork out of it, and it's the best way to determine exposure. When you're doing these air sampling, you want to know what kind of exposure limit you're going to use. A lot of chemicals have multiple exposure limits. They'll have exposure limits for the 8-hour shift. They can have 15-minute stells. They can have CELA limits that aren't to be exceeded at any time. And a lot of times chemicals will have multiple of these limits. They'll have a TWA and a stell or a TWA and a ceiling limit. when you're determining if you need what kind of respiratory protection you need to use, you need to consider this. If you had a process where somebody was doing 15 minutes of handling benzene, you wouldn't want to have an 8-hour time-weighted average sample collected to say, oh, look, we're in perfect compliance. Our 8-hour time-weighted average is, underneath what the limits are. You're going to want to focus on what the actual task is and leverage the appropriate limit for that and select your respiratory protection off of that. The exposure limits they're going to be referenced. I only mention this for the collection of samples. A lot of times you don't necessarily have to consider your exposure limit, except for the type of material you're looking for if you do the accurate material selection. The one thing I state this for is that these exposure limits are wildly different from one another, and oftentimes they require more accuracy in the instrument that you're trying to quantify it with. You want to be careful of sampling limitations and interferences whenever you're doing this sampling. This is something I see a lot of, where people will be dealing with data that's not necessarily accurate. If you're using like a gas sensor to determine what kind of respiratory protection you need to use in an environment, there are a lot of interferences with them. You need to know the interferences. If you're looking for carbon monoxide, hydrogen's going to wildly impact those results. Same thing with formaldehyde. If you're using a formaldehyde meter, carbon monoxide's a huge positive interference for that in a lot of ways. A lot of instruments have very significant interferences there. Nitrogen dioxide, sulfur dioxide, there are interferences that carry between those. If you have sulfur dioxide in an environment, it can have an impact on what your actual readings are. So something to know with the gas sensors. Particulate types are another thing that you need to consider. There's all sorts of fractions of particulate. All of those pictures of instruments in the bottom, they all measure dust. They measure different sorts of dust. You have total dust, you have respirable dust, you have inhalable, thoracic, inhalable fume vapor. All these different things are measured differently. You just want to make sure if you're going to quantify your environment with breathing zone samples that if it's a total dust limit, measure total dust. Don't measure respirable dust and compare it to total dust. Likewise, if it's a respirable limit, taking a total dust sample and comparing to that is not going to be accurate. You not only want to make sure you're protecting your employees, you also want to make sure you're not overprotecting them, where you're finding a hazard where hazard doesn't exist because of how you're doing your sampling. Passive media is another thing that I run into with over-reporting results. If you get droplets of solvent in the meter, because there's a fairly large opening on those, and that they are more vulnerable to that kind of thing. Impactors can get blocked if there's a lot of dusts. And be careful with aerosol meters, the real-time aerosol meters. There's a lot of issues with those and a lot of ways you can get into trouble with them if you don't know what you're doing with them. I'll talk about that a little bit later. I have a little case study I'll speak to. Assign protection factors. So this is straight from the OSHA standard. This is basically a means of determining what your assigned protection factor is for the type of respiratory protection you're putting in place. You can see there's air purifying respirators, powered air purifying respirators, supplied air, self-contained breathing apparatus, and you can see for each of these, half mask, full face piece, helmet, hood, there is a factor that goes with it. The one thing I would like to speak to on this is, one is you see the powered air purifying respirator. These are becoming a lot more popular in welding environments because, one, a lot of them are loose fitting, so people can have facial hair and wear them. And two, they provide cooling and they provide a lot of protection against the metals that are developed. So a lot of firms are just deploying these everywhere. The one thing you want to be certain of, you see that this says 25/1000 for the helmet hood. That is based on the contention that the employer must have evidence provided by the respiratory manufacturer that testing shows that the protection factor is actually 1,000. I just say that because I see a lot of facilities that are deploying these things as protection against concentrations, and they don't have that on hand. And usually most manufacturers can provide that data readily if you request it. It's not a bad idea to have it on hand because you may be asked it in the future. It's nice to have that readily available, saying this is the data that they provided that proves that that's the actual protection factor for that device. There's a few other considerations when selecting a respirator that I want to speak to. OSHA standards, you want to consider these some of them will have a little different requirements that don't necessarily jive with the APF table that I showed in the respiratory protection standard. See, the lead standard has a statement in it that says, it's provide employees with full face piece respirators instead of half mask respirators for protection against lead aerosols that can cause eye or skin irritation at use concentrations. So that's something that if you went through the APF table, you may not necessarily arrive at a full face piece respirator. Likewise, employers for asbestos must not select or use filtering face piece respirators for protection against asbestos fibers. So that's a notation that would contradict in a way what you may find going through the procedure for the respiratory selection using the actual respiratory standard. You want to make sure when you're selecting a respirator that it's protective against the type of contaminant. If you're trying to protect somebody against hydrogen sulfide gas, you take a air sample, it comes back where it's like, oh, we need a protection factor of 10. You want to make sure you're just not putting a particulate respirator on them, because that's not going to stop any of that hydrogen sulfide gas. It's the case with a lot of gaseous substances. Particulate respirators, it'll pass right through them. You also want to make sure if you're selecting a respirator that your cartridge is proper. I've seen this at a lot of workplaces as well. Somebody has exposure and they go ahead and they get on Grainger, they order a negative pressure 3M face mask with the cartridges, and they just have dust cartridges on them. Or they have organics, particulate combo cartridges, but they want to protect against acids, or they want to protect against formaldehyde. There are special made cartridges that are for those chemicals. You want to make sure you're selecting something that's going to be protective, that it's not going to pass right through that, or some of it will pass through the protection that the filters provide. So when doing this, OSHA talks about a maximum use concentration. This is how they recommend going through and determining, what kind of respirator you need to use. And that's basically the maximum atmospheric concentration of a hazardous substance for which an employee can be expected to be exposed. And you multiply that by that's what the MUC is. Pardon I lost my train of thought there. You want to calculate the MUC by multiplying the assigned protection factor. We saw that on the table. So if you're using, a mask that has a 10 protection factor, and you multiply that by the selected exposure limit, and that's going to determine your MUC. So the MUC is the upper limit from which the respiratory protection would provide protection for the employee. And whenever they are exceeded, whenever you exceed that MUC, you need to select a higher class of respirator. An example calculation for the MUC, the calculated MUC, as I said, you multiply the protection factor by the exposure limit. So let's say you have a process that has toluene. You have a solvent process, the individual is using toluene, the PEL is 200 part per million, the TOV is 20 part per million. Pretty different exposure limits between those two organizations. The employee wears a half mask negative pressure respirator with organic vapor cartridges, APF of 10. The cartridges are appropriate. And you did a couple changes to the process, so you want to collect full shift breathing zone sample to determine, what your concentrations are. And you measure 500 part per million in the analyzed sample. So the MUC for the assessed process, this new process, revised process, would be 10 for the protection factor, times 200 if you're using the OSHA PEL. That means it would be good up to 2,000 part per million. You have 500 part per million, everything's okay. Your respirator is protective. If you're using the TLV, however, you can see it's a much different result. 10 APF, 20 ACGH TLV, that's 200 part per million. That shows that your concentration exceeds the APF of that respirator. Typically, when I'm advising my clients, I always like to adhere to the most stringent limits. That's not always reasonable. It's more or less up to the employer, a lot of cases, to do that. If there's an OSHA PEL and there's a more stringent limit, that's an advisory limit. It's basically up to what you're going to select. You want to have a respirator that's going to be protective against that concentration that's developed. I'm going to talk about a couple little case studies of things I found that I thought were interesting in my travels. One instance I found an individual wearing this thing, a respirator. And I thought it was so wild when I saw it. I couldn't believe it was such an odd looking thing. I couldn't believe the guy was wearing it. It's basically a device that is meant to be worn for people with beards. That's what the whole focal point of it was, that it's difficult to wear negative pressure respirators with a beard. It's not really, doesn't give you the protection. So here, this gets around the beard. There's a couple problems with this. I mean, you with voluntary respiratory protection, all of these things aren't necessarily required. But something like a medical clearance, I think it would be hard to get medically cleared for such a thing. If you're trying to use, if somebody comes to you and says, hey, I want to use these instead of an N95, I want to use these instead of a negative pressure respirator, that I use it at home, it works great. Just remember, it's going to be really hard to get fit tested for something like this. I don't think it's really possible. When you look at this respirator, if you call it a respirator, you can see what would stop you from breathing through your nose. Well, they have a nose clip that you clip on your nose to stop you from breathing through your nose. So I don't think that's a legitimate way of doing it. And the guy I saw using it had actually removed the nose clip because I'm sure it's not very comfortable. The other thing is this a NIOSH approved respirator, as I said before, and it's not. It won't ever be NIOSH approved. They don't even have a category for this style of mask. I know they attempted to get it approved. It's not going to be approved. It's this type of thing, when these kind of masks, these kind of style masks, if people want to use it at home in wood shop, that's fine. I just don't think this kind of mask has any business in a industrial facility that's regulated by OSHA, just because of those things with difficulties with any sort of medical clearance. It's going to be hard to do it. And also, it doesn't really provide the protection that I would want to see in an industrial environment with the problems with the fit. It's kind of like more of like a snorkel type, like escape respirator you would see type seal. So another thing I found with a case study was real-time aerosols and objective data. I mentioned that before about how you got to be careful. And this was an instance where they were using real-time aerosol monitor. They were getting a cadmium coating off of glass by crushing it. And they measured the cadmium in the crushed material, and they had a correction factor for the meter. It seems perfectly fine. And then they were using that to do their measurements on the floor. There's a couple problems with it. One is they were counting the glass and the percent weight, which the glass was more of like a gravelly substrate when it was done. It didn't put much up in the air. So they kind of didn't really do the most protective, theoretical style calculation like they did. You'd really need to be a little more protective when you deal with that. You should have went with the coating. Cadmium's an 8-hour TWA, and they're just doing spot readings with this thing. Again, that's not really the way that you'd want to protect against it. You'd kind of want to have full shift data to compare against that full shift limit. That meter that's there, and those style meters, they typically use impactors and cyclones. So they measure just fractions of material, and that's what they're good at. They're really good at measuring respirable dust and real small, fine particulate. They're much less effective at measuring total fractions. OSHA regulates cadmium as a total fraction. So right there, you're not really measuring potentially what OSHA regulates for. And therefore, when you're selecting a respirator, again, you're using data that's not really true to what the true exposure is. The other thing is that meter can't really be calibrated. I refer to it the same way you'd calibrate a gas meter by spanning it to a cylinder. The way you do aerosol monitors, if you want to calibrate them, is you have an inline filter with them, and you send the filter in. The filter tells you what the number was at laboratory analytical, and you can use that as a way to correct your real-time measurements because it doesn't measure all particulate the same. So it's typically, if you're going to use it in an instance like this, you want it to have it be calibrated to the environment. Again, this just goes back to what I was saying before. Defensible data. You need to be able to explain what it is you're doing and be able to defend it if people look at it and wonder if this is actually being protective for the employees. Now I believe it's George's turn.
Thanks, Eric. Appreciate it. We're going to move on and talk about a number of other aspects to that required program. The first element being medical evaluation. So why do you need a medical evaluation? the respirator itself can be a hazard. It puts a burden on your breathing, and depending upon a whole variety of conditions, factors, that is what could limit someone's ability to use the respirator. That is, they could have different kinds of conditions where they can or can't use a respirator. So the first element we're going to talk about here just has to do with the evaluation. Has to be done before you use it, and it has to be done before you get fit tested. We'll talk about fit testing in a little bit, but the key is that if you're somebody conducting fit testing, you need that medical clearance to even begin a fit test. You can't do it without medical clearance. And certainly it has to be done before somebody is using it. And so these are things that need to be done up front, not later on in the process. What's really important to understand is the fact that when we're talking about any form of medical program, there's an exchange of information between the company and the healthcare provider. The OSHA term is a physician or other licensed healthcare professional within the scope of their license. I'm going to say healthcare provider, or I may say physician or doctor. But the key here is that that healthcare provider cannot give you an accurate answer if they don't have the correct information. So how is the person going to use the respirator? This is not just a question of what make and model. This is a question of how they're going to use it. So we start with that make and model. How heavy is it? How much breathing resistance does it have, and so forth. How long is the person going to use it? Is this something that, yeah, they're going to use it for 5 minutes once a day in order to do an inspection, or are they going to wear it all day long? What is the physical activity the person is doing when wearing it? Is that going to be a light workload? They're standing and monitoring something. Is it going to be a heavy workload? Do they have to do manual lifting? Are they going to do carrying? That's going to change their breathing rates. How they breathe through the respirator is affected significantly by those kinds of things. What other kinds of protective clothing are they going to be wearing? It's very different to be wearing a respirator in full turnout gear, doing firefighting, needing to physically carry things in and out of a burning building, than it is to wear a PAPR while you're sitting still visually monitoring something. Again, very different circumstances. And they need to have a copy of your written program. So all of those elements have to go to that healthcare professional for them to even give you an answer. So the first piece here is, if you're not providing all that information to whoever's doing your medical assessment, you don't have a medical assessment yet. That all has to go to that healthcare provider. Now, there's a process. Once the healthcare provider has the information, they start with a mandatory questionnaire. Although it's mandatory, you can look it up in the OSHA standard online. They are the ones who are administering it, and it's confidential between that healthcare professional and that employee. Depending upon how the individual answers that mandatory questionnaire, that's going to see where things go. And the healthcare professional may do a variety of follow-ups. Frequently these days, they'll have some kind of a questionnaire to ask a few more questions, and then they'll bring the individual in for different kinds of tests, different procedures, and so forth. There is no specific procedures that are dictated in the standard. It's based on medical practice. And then the information goes back to the company. But the only information that goes back to the company has to do with medical clearance. Is that employee able to use a respirator, either unconditionally, that is within all the limitations you set up front, or they can't use it and they have some additional limitations besides the ones that you specified for original use. Do they need follow-up evaluations? It may be that they can only partially assess the employee, and you need to do follow-up assessments. And the employee also needs to receive a statement that they've gotten those recommendations. So those are all the pieces that go back to the company. That kind of covers briefly what medical evaluations are. Now, once you've had that medical evaluation and you're using the respirators, another element here has to do with proper maintenance. And the real question starts with, are respirator cartridges good forever? That is, if you have a respirator, when do you need to change it? And we start with filters. If you have filters, it's based upon how hard it is for that employee to breathe through the filter. If it's a negative pressure respirator, that is something that the employee needs to pull air through with their own lungs. And as they start to have resistance to breathing, then that employee decides that they need to change the filter. If it's a filter on something like a powered air purifying respirator, there's an actual gauge that you put on that each time you use it to see that the airflow is adequate. So filters are pretty straightforward. Cartridges are not. Cartridges don't change in resistance. They simply collect the chemical of concern, and at a certain point, they can't collect anymore, and it comes through. There's breakthrough. There's two ways to address that. One are end of service life indicators. This happens to be an old mercury type respirator, and as the mercury comes into contact with it, it starts to change from an orange to a dark brown. And when it hits that darker color, that means that it's time to change it because the material will be coming through. There are more and more products that are starting to appear on the market. I have not had the time to really look at all of the different products, as everything really has expanded in that area over the last number of years. The last one is a change schedule. That is, instead of having a gauge on the respirator saying it's full, we change it based upon the conditions. And we're going to take a quick walk through an example of change schedule. Now, I am in no way supporting a specific company. You need to go to the company that you get your respirators from. You can get any NIOSH approved respirator is appropriate. You will have to, for change schedules, go to that company. There is no such thing as a generic change schedule. You need to know the exact make, model cartridge that's in the respirator you have in order to determine a change schedule. So you have to go to the manufacturer. We're going to happen to pick 3M today. If you go, they have an online tool. You start by putting in the contaminant. In this case, on the upper right, it says toluene, and we've selected toluene along the line. On the bottom, you can see toluene was selected, and we have to say what that concentration is. You have to know what that airborne concentration is, or you can't figure out a change schedule. But you need that same number to determine what the appropriate protection factor is. So again, you have either, most of the time, you've measured it. If you haven't measured it, you've calculated it somehow, so you use that number. At that point, on the bottom, you can see we've selected toluene. So now we have to say, what are the workplace conditions? We start at the top of that. What specific cartridge do we have? That is, we have a model XYZ small. You need to know that exact cartridge. You then have to determine what the other environmental conditions are. What's the air pressure? What's the temperature? What's the relative humidity? And at the bottom of the list, what's the physical workload of the person doing the work? Is it light? Is it moderate? Is it heavy? That really is how much breathing are they doing. That is how much air is coming in and out of that cartridge that has to be have the contaminant removed. We then go and calculate, and in this case, we can see that there's 150 parts per million at the bottom. We've got our conditions. And unfortunately, the slide here does not quite work the same way, but this would have the estimated service life is 17 hours. So that cartridge in that environment can be used for up to 17 hours. So basically, if you're spending the entire day, and if we're basing this on an 8-hour time-weighted average, we're talking about the entire day. Therefore, every other day, you need to change the cartridge. So that's how that process works. We need to talk about fit testing. And fit testing is needed after that medical evaluation before you use it. And it is necessary if you have a tight fitting face piece. So everything that you see on this picture are tight fitting face piece respirators. You do not need a fit test for a loose fitting respirator. So a PAPR, powered air purifying respirator, that has a loose fitting helmet or hood like this, you do not need to fit test. In fact, there's no way to fit test it. The protection is based upon air flowing past the seal, not having the seal protect. There are two different kinds of fit tests. There's qualitative and there's quantitative. The qualitative fit test can be used for anything that has an assigned protection factor of up to 10. That basically says your half-face respirator can use a qualitative fit test. The quantitative fit test has to be done if you have a full-face respirator. It can still be used for a half-face, but must be done if you have a full-face respirator. What's important to understand is that you need to go to the specific protocol for those for that fit test and use it. A qualitative fit test, and there are 4 different kinds, has some kind of a challenge. So if you're going to use the saccharin test, that means you make up saccharin. That means that before you do the fit test, the person has an ability to put the respirator on. They do some things. You check to see whether they can detect saccharin in the first place. You then expose them and see whether they notice or detect the saccharin during the test. There's a whole series of specific activities they have to do. The key here is that a fit test using the qualitative protocols has taken certainly 15 minutes is a typical minimum amount of time to go through the entire process. Quantitative fit testing. This measures the amount of contaminant outside and inside and makes a comparison. And so there's no judgment necessary on the part of the person who is being tested. The instrument does that measurement. And there's a couple of different mechanisms for doing it. One of them takes just room dust and measures it and sees how much room dust is removed. Others apply pressure and see how the pressure difference changes. Again, a couple of different mechanisms, but they have a quantitative and numeric way to make that assessment. In addition, we have to properly maintain a respirator. Noted, this is required whether respirator use is mandatory or whether it's optional. And so even if it's optional, you can't have a dirty respirator which creates illness in the person who's wearing it. On the left is kind of one of my favorite photos. It is pretty common to see a respirator kind of hung with the canister down, with the face piece, excuse me, face piece up, and it's collecting dust from the room. And I'm going to bet that your first breath out of that respirator has a whole lot more contaminant to it than just breathing the room air. And so that's really one of the key elements. We've got to make sure that we clean, disinfect, store it correctly. We need to look and inspect it, repair it, or discard it, depending upon what condition it's in. And with that, I will hand it off to Rebecca.
Hi again. Part of the respiratory protection program is that initial training. So that's when we're going to tell and talk to the employees that are going to be using respirators. What are the general requirements of this respiratory protection program? You know, how do they actually put a respirator on, take it off, and maintain it? And every time they put a respirator on, they do a seal check. So this training is, how do you do those things? What are the limitations of use? There are some people that when they put a respirator on, it's kind of, I call it the Superman syndrome. They think they can do anything, and they maybe were issued a respirator for some volatile organics, and they've got a carbon organic filter on it, and then their job may change, or they have to cross train into another area where there's maybe an acid mist issue. Like Eric was saying before, they have a respirator, they'll just use it over there, but they're all very specific for what they can and can't protect against. So talking to them about limitations of use, they don't protect you against an oxygen deficiency, for instance. And then maintenance, as George was alluding to, how do they maintain that? Do you have a repair department that they should take something to if their straps on the respirator start getting bad, or develops a tear, or they're missing a piece to that respirator? So teach them how to inspect the respirator every time they go to use it. Are all the pieces in that respirator in place? Tell them why the respirator is needed. You need to review what the hazards are. What are you protecting them against? And if you didn't have that respirator, what are the symptoms of overexposure to that chemical that you're protecting them against? How could they compromise the respirator? How could they damage it and so it wouldn't protect them? If you looked inside of a elastomeric half mask, you'll see a little flap on the exhalation valve, and if that's missing, air follows the path of least resistance. Or if it gets hardened and it doesn't make a good seal, then air is going to come in there and not go through the filter. So it's important to always inspect the respirator before it's used. You have to know what concentrations of contaminants are present. We've talked about that many times, and if everybody should know that what the medical signs and symptoms are of the chemical that they're being exposed to, as well as just wearing a respirator. As George talked about, it increases the load on your cardiovascular system. So you could have dizziness, you could have increased heart rate, things that maybe when you're wearing your respirator, you're getting some symptoms that something's not quite right. And maybe things have changed in your own personal health that you need to be reevaluated. Or if all of a sudden they start getting symptoms of the chemicals that they're working around, maybe they start coughing and they're working around at acid mist, and that's a sign of breakthrough, right? So their cartridge is no longer good. So those are the things you want to train on. And then you have to retrain at least annually. And we say at least because more often, if saying it nicely is if their performance demonstrates misunderstanding. So you manage by walking around, and you're walking around and you see people with beards or with facial hair, and maybe they just didn't remember that they can't wear a beard with a tight fitting respirator. Time for retraining. Or you look at where they're storing the respirator and it's hung upside down, or it's squished in between some heavy objects and deforming the mask. It's time to let's review what this program is and how you need to take care of your respirator. You need to retrain if conditions change. Maybe you changed the manufacturer of respirators. Maybe something happened in the manufacturing of the supply chain that now you're going to change. You can't just change cartridges if you can't get a cartridge, because those are, if you're buying a 3M respirator, there's a 3M cartridge that fits that. So if you change anything, you have to retrain your employees on that. You can also, maybe the conditions of the use have changed. Maybe the concentration of contaminants have gone up or have gone down, and you can change the level of respiratory protection that you're advising on. So that's all part of a program evaluation. So what you're really looking for here, as I said, you're looking, maybe there's a change in the process. Maybe it's gotten a little worse, maybe you've added equipment, or maybe you've done some engineering changes with ventilation that now you think you've made it better. Maybe you don't need a respirator anymore, or you can go from a full face down to a half mask. So those are things that the person that's in charge of this program does. You should review your written document. Maybe you've changed your healthcare provider, or you've added jobs or tasks that require respiratory protection. Maybe you didn't have a voluntary program before and you've added that. So there's always something to do with that respiratory protection program, the written module. And so that at least annual look at that is always worth it. Then the whole piece of management by walking around, that's when you see what's happening. That's when you can engage your employees and ask them, how is it working? Because you can think all you want that you know exactly what's happening on the floor, but unless you go and observe, unless you talk to the employees, you're probably missing something. So in the regulation, it says the employer shall conduct evaluations of the workplace as often as necessary. So this isn't required that you evaluate it annually or semi-annually. You have to evaluate it enough so that you're making sure that the current respiratory protection program provisions are meeting the needs of your company, and it continues to be an effective program. Oops. We'll finish off here with just some common mistakes we see, and this is just a few slides here. What's wrong with this slide is that this person, you'll notice a little red filter in the bottom. He's actually being monitored. So collecting a dust sample to see what his personal exposure is. But he's wearing a respirator, and around his head, he's got some sort of a head cover, and he's wearing the respirator on the outside of that. It should be on the inside of it. And the reason why is that that's the last thing to come off. When you come out of a room or an area where you're having someone wear a respirator, that's the last piece. So the head cover would come off first, and in this case, you can't get the head cover off. So that's one of the issues with this slide. This one should be stored in a closed bag. As George showed before about his respirator, the contaminants can get inside the mask. And what you see here is this is a pink denotes a HEPA filter, a particulate filter on this particular mask. If you had if you didn't have your respirator in a bag and you had an organic vapor, it's going to use up that organic vapor sooner, that cartridge sooner than it would if it was in a contained bag, because it's being exposed to other volatile organics just out in the atmosphere. If you put things on top of your respirator, this elastomeric respirator, it can deform the mask, and then it's not going to fit your face properly. So it should be stored. That's one of the things that, again, when you're evaluating your program, go around and look where are they. There's typically an assigned place where you want those respirators kept, and are they keeping them clean? Are they keeping them there properly? So those are all things that you can check. You can also check by looking to see what their face looks like. Do they have a beard, and are they wearing a respirator? Some places the respirator use is so infrequent that before they have to use it, they'll actually shave. So the hair can't cross underneath the seal of the respirator. That's what you have to look for. So some mustaches will work, some will not. The soul patch over here, that works just fine, as long as it doesn't interfere with the seal of the respirator. And you don't even, I like to say, do the credit card check, but even the stubble that's very popular, can't wear it. You need that skin contact. So that's another thing to look for. Actually, OSHA has a whole, I just grabbed these off of an OSHA chart. They've got a whole poster that you could place in your workplace that talks about what's acceptable and what's not. And we'll just end here with as a card for George and his contact information. And when you have access to the slides later, you'll have this. And then there's a similar one for myself and one for Eric. So if there are any questions, we can take those now. Although I don't see anything in the chat.
I have a question, George. So a medical professional obviously, I assume most people are using occupational medicine professionals to do a lot of the evaluations, but in theory, could someone like a dermatologist do an evaluation for this because it's in the Practice Act, or what would it be?
I mean, OSHA does not dictate what medical practice is, and each state has proper licensing. What I will tell you is that in general, legally, anybody with a medical license can legally do any type of medicine. At the same time, it is much more their insurance and their professional practice that limits what they should be doing. And that's the challenge, is that most certainly know what those limitations are and function within it. As with everything, there are probably a couple of folks who are stretching a little further than their actual knowledge and experience. I would focus, one way to look at it is that occupational medicine is its own specialty. So if you're going to have heart surgery, I really want to go to a cardiac specialist. If I'm going to have any of a variety of other things, I would go there. I would encourage everybody to be looking for a board certified occupational physician. They're easier to find these days than when I started, but they're still not all that prevalent. But I'm going to say almost any, today, most healthcare communities are large organizations, and they have it someplace. They may not have it being resident at that particular clinic, but they will have it in their system. And so that person can sort of be the contact. They'll do the physical work in the local clinic, but that person can oversee it. So that's what I would encourage people to look for.
And I know obviously MDs and PAs can do that. Are nurse practitioners also included in that in the state of Wisconsin?
I'm going to tell you that the licensing boards are who define what's within the scope of the license, and I'm going to tell you that there are different licensing boards who agree or disagree as to what other licensing boards are or are not allowed to do.
Gotcha. That sounds like a very answered question. I love it. So, but I completely understand. I mean, scope of work and all that different stuff. So, okay.
Yeah,
well,
the nursing community will, they certainly can do assessments, but what they can do other than assessments is up to discussion, and there's a debate on that, and I'm staying out of it.
right. I completely understand. So, but great presentation, guys. Thank you very much for your time. As Rebecca had mentioned, we can get out a copy of this presentation to everyone that was on here today, in case you had any coworkers or anyone you know that were interested but just couldn't make it today. I know all the participants today as well are going to be posting a copy of this to either their website or YouTube as well. But we thank you very much for coming out today, all three of you, to Rebecca, Eric, and George. Awesome. And everyone who's in the crowd today on this rainy Friday, wherever you may be. Hope you have a great weekend. And on behalf of the Greater Milwaukee Safety Council Board, just thank you everyone for coming, and have a great rest of the weekend. Bye, everyone.
Thanks so much.